In this video, we're going to look at one of the topics we touched on in National 5, and we're going to do a brief recap of some of the key points that are involved in working with this topic, and that is solving trigonometric equations. Now, we have to make sure that we remember the basics and understand those from National 5 before we can progress on to the next level and the next set of material based on this. So, let's have a quick refresher of these. The first thing we need to make sure that we remember is something called the cast diagram. Now this diagram, which is shown here, helped us when we were solving trig equations and we ended up setting a limit on x that extended beyond the first half of the period of the function. So for example, if we were told when we were solving the equations that the value of x lay somewhere between 0 and 360. If we remember the general shape of the three trig curves, sine, cos and tan, we'll remember that there was tended to be more than one solution for all three of them within this domain. So we had to make sure we were able to find both solutions. And this diagram helped us with that. Now, when we were solving it, which we'll look at an example of later on in the video, we had to remember how the solution to that equation related to all of these sections. Each of these meant something different, the a, the s, the t and the c. What they told us is which functions were positive within that section of the graph. Because what we can think of is the top of the graph being 0, the first one here being 90, this one being 180 degrees, and this one being 270 degrees. What this diagram told me was which graph was positive within each of those sections. So the section from 0 to 90, all three of them were positive. Section from 90 to 180 degrees, the only one of the three that was positive was the sine curve. The other two are both negative. 180 to 270, the only one positive was the tan curve, and 270 all the way up to 0 or 360 degrees, the only one that was positive was the cos. Now this allowed me to get the solutions that are required within the given domain for the function. When we were solving it, when we got an answer for the function, we assumed it was x, and that always lay within the first section here. To find our other solutions within our other sections, we followed a couple of quite easy little calculations to do. If it lay within this section here, so the S section, the calculation we would follow in order to calculate it would be 180 degrees, so the upper part of our limit, take away whatever the value of x was. So if x was 45, we'd do 180 minus the x. Our second solution, which lay within here, would be 135 degrees. If it lay in the t section, it would be 180 plus the value for x. So again, if it was 45 degrees, the solution within this section would be 180 plus 45, 225 degrees. And if it lay within the c section, it would be 360 take away the value of x. Now, all of these parts came into play whenever we solved an equation that involved trig, and we'll show an example of that in just a moment. Now, one other key thing we have to make sure we remember is our exact values of sine, cos and tan. And these can be found by looking at two separate right-angled triangles. Now, the key values we have to remember is sine, cos and tan of 0, 30, 45, 60 and 90 degrees, which can be brought up in these two triangles here. Now imagine this triangle here, I've set it up, and I'm going to tell you that this one here was 30 degrees, and this here was 60 degrees. Thinking back to when we did their exact value triangles, what we're able to then say is we had this side which was equal to 1, this side here was root 3, and this side was 2. And if this triangle was a triangle where we're looking at 45 degrees, well, both of these angles were the same. Remember, a triangle, all three angles add up to 180, and this being a right angle triangle, this one's 90, which meant that my two sides here were given by that. So I had 1, 1, and then the hypotenuse being root 2. Now these, coupled with our favourite relationship from National 5, saw katoa, allowed me to calculate the exact values of each function at 0, 30, 45, 60 and 90. Remember, SOHCAHTOA tells me for sine, I do opposite over hypotenuse, cos I do adjacent over hypotenuse, and tan I do opposite over adjacent. Now think back to when we did the actual graphs of all three of these curves. At 0 degrees, sine was 0, tan was 0 and cos was 1, so that is fairly straightforward and easy to do. When we were at 90 degrees, sine had hit its maximum value at 1, cos had come back down to 0, But tan, remember, had discontinuities at 90 degrees, 270 degrees, and so on. So it actually had no value there. It was non-applicable. You couldn't get tan of 90 degrees. Now, looking at the triangles, we're able to calculate the others. So sine was opposite over hypotenuse. So if I had 30 degrees here, opposite was 1, hypotenuse was 2, which meant that sine of 30 was 1 over 2. For 45, again, opposite over hypotenuse, and it didn't matter which of these two angles you picked for your 45, you get the same result either way. You'd end up with 1 over root 2. And for 60 degrees, start here, and again, opposite over hypotenuse, root 3 over 2. So for sine, those would be the exact values I'd get for those ones. For cos, same idea, except I just have to remember I'm using the k part of my relationship, so it's adjacent over hypotenuse. So for 30 degrees, I would end up getting root 3 over 2. For 60 degrees, I'd end up getting 1 over 2. And for my tan, for my 45, I would actually end up with 1 over root 2 again. And for tan, opposite over adjacent. So for 30 degrees, I'd end up with opposite over adjacent, so 1 over root 3. For 60, I'd end up with root 3 over 1, so just root 3 all on its own. And then for 45 degrees, opposite and adjacent, I would end up with 1. This table here is your exact values you have to remember. Now, we talked about these very briefly at National 5. You have to make sure you remember this table and how to calculate it for any work we do at higher. But the key thing to remember, always remember these two triangles. If you can remember them, you'll be able to recall them at any point when you're working it through. So very quickly, I just want to recall and recap a couple of examples as to how we use the cast diagram and our exact values to solve these equations. So let's imagine I want you to solve the equation sine x equals a half. Well, what we have to do is first recall our cast diagram. So our cast diagram looks something like this. Now, when we are solving these, the first thing you do when you get it written to this point, when it's sine x, cos x, or tan x equals something, is look at the sign here. Now, I know sine x equals a half. This is a positive number. So I want the sections in my cast diagram where sine is positive. I know sine is positive here and here, so I know my two solutions are going to fall in this part of the diagram, which means when I find a solution for a half, to get the solution in this, I do 180, take away the solution from there. So I know then that my x is going to be given by sine minus 1 of a half. Think back to the exact values table. Sine minus 1 of 1 over 2 was 30 degrees. So I know that that's the solution for this section here. I want my second solution, which is in this section, but I know the solutions in that section are given by 180 minus this. So I then know that my two solutions are 30 degrees and 180, take away 30 degrees. So my two solutions in this case are 30 degrees and 150 degrees. Those are my two answers for x when I've got sine x equals a half. So, working this through is fairly straightforward. And if it's a negative, it's actually the same steps. There's only one extra thing we have to take into account. So let's imagine that I want to solve the equation cos x equals negative root 3 over 2. Again, the cast diagram comes into play in this and is a key thing to calculating the answer for this. First thing we have to do is look at the sign. So it's when cos is negative that we're looking at. Well, I know cos is positive in the C and the A parts, which means that my two solutions are given here. Now this is when we do that extra little step to calculate x, because we do cos minus 1, but we ignore the sign. So we do cos minus 1 of root 3 over 2. To calculate that extra angle, we have to do cos minus 1 of root 3 over 2. What that then means, in this case, is that x equals 30 degrees again. But we don't want that solution. We want the two solutions in here. Well, I know the solution in here is given by 180 minus x, and the solution here is given by 180 plus x. So to get my two answers for x, that's exactly what I have to do. I have to do 180 minus 30, and my second solution given by 180 plus 30. So in this case, 180 minus 30 gives me a solution of 150 degrees, and 180 plus 30 gives me a solution of 210 degrees. Thinking back to how we solve these, it's fairly straightforward. The only difference is when this is negative, we have to ignore the sign to get that and just use the calculations for the correct sections of the cast diagram that we've figured out. This is a hark back to the National 5 material. We covered how to do this. We're going to step it up a bit in the next video and look at how to solve slightly more complex trig equations than this.